Good morning, students and friends. Today we are going to discussing about linear integrated circuits and its applications. So linear integrated circuits, also known as linear IC, so are the analog electronic circuits that operated by using linear signal processing. Linear ICs are those integrated circuits which are designed to generate an output signal that is a linear function of applied input signals. Since linear ICs are analog integrated circuits. So linear IC is a solid state analog electronic device that work by using continuous time signals. These ICs are characterized by having an infinite number of operating states. So we have types of linear integrated circuits are there. So this operational amplifier, voltage regulator, analog multiplier, and comparator. So first we is discussing about operational amplifier. So operational amplifier are most widely used linear integrated circuits in a wide range of analog electronic circuits. The name implies that operational it performs some operational mathematical operations like addition, subtraction, integration, differentiation, etc. And it amplifies the weak signal into strengthened signals. It amplifies some weak signal into strengthened signals. So basically, an electronic is a group of electronic components connected for a specific purpose. In a multiple electronic components are integrated in a single chip of semiconductor, then the chip is called as integrated circuits. Then the chip is called as integrated circuits. So advantages of integrated circuits are so compact in size, lesser weight, low power consumptions, reduced cost, so improved operating speeds. We have two types of integrated circuits. One is analog integrated circuits, another one is digital integrated circuits. First we'll discuss about analog integrated circuits. That is the first topic is operational amplifier. So already told you that operational amplifier, also called as APAM, is an integrated circuit which can be used to perform various linear and non-linear and mathematical operations. An APAM is a direct coupled high gain amplifier. Next we have the construction of operational amplifier. So APAM consists of different amplifiers, a level translator and output stage. A differential amplifier is present at the input stage of an APAM. Hence the APAM consists of two input terminals, and those of the terminals is called as inverting terminal and non-inverting terminal, and one output terminals. Next one is types of operational amplifier. So the operational amplifier represents with a triangle symbol having two input and one output. So op-amps are basically, that is, we have two types. One is ideal op-amp, another one is a practical op-amp. So an ideal op-amp exists only in theory part. It does not exist practically. And practical op-amp it's used for in the practical purpose. So ideal op-amp, it having some input characteristics. So based on the characteristics only we are going to design the circuits. So the characteristics are, so input impedance is very high, that is infinity, and output impedance also, that is very low, that is zero resistance, and the voltage gain of op-amp is very high, that is infinity. And if I'm taking, that is infinite, that is differential input voltage, and VI and V naught, that is VA, V is differential input voltage must be zero, so that the signals of any frequency without any attenuation it will be there in the output side. And the common mode rejection ratio is also infinity, and the sleeve rate is infinity. It means, so ideal op-amp will produce a change in the output instantly in a response to an input voltage. Next one is practical op-amp. So op-amps are not ideal, and from their ideal characteristics, because of some imperfection during manufacturing, the equivalent circuit of practical op-amp is shown in figure. And in practical op-amp also, some of the characteristics are there that is very important. So that is input impedance, it's in order of mega ohms, and output impedance in order of few ohms, and open loop voltage gain, so that is AV, that is output divided by input, will be very high. Next we have op-amp applications. On op-amp applications, it the circuits is used to be linear if there exists a linear relationship between input and output. Similarly, a circuit is said to be non-linear if there exists a non-linear relationship between the input and output. So op-amps can be used both linear and non-linear applications. The following are the application of the linear applications. So that is, first one is inverting amplifier, another one is non-inverting amplifier. So third one is, that is, we have the voltage follower. So first application is inverting amplifier. The inverting amplifier takes the input through its inverting terminals through a resistor R1, through that is resistor R1, inverting amplifier through a resistor R1, and to produce its amplified version of the output at pin number 6. The amplifier not only amplifies the input but also inverts, that is 180-degree phase shift between the input and output signals. When you are applying the input signals to the inverting terminal, in output it's 180-degree out of phase in the output side. So pin number 3, that is, it's grounded, that is grounded, and pin number